This is a defend yourself question. And we're going through this now, okay? I'm not going to tell you what the question is, but I will tell you what you should expect. I have a multiple choice question on this exam, where every single answer could be right. Okay, and now you're like, excuse me? Yes, every single answer on this exam, on this specific question, not on the exam, on this specific question. Yeah, I'll tell you right now, number 31, all right, to be very specific, number 31 has 5 responses, and every single one of them could be right. So part of your job this time is going to be to explain to me why you chose the answer you did. All right, defend yourself. Okay? This is what they call an apply and analyze level question. Okay? These are the kinds of questions that you might see at some kind of like medical school, etc. I had somebody come back from medical school and they were talking to me about their exams. And I was like, oh, sick, those questions finally made it to medical school. I can finally put them on my exams. So, in an effort to help prepare you for those kinds of questions, there is one where I'm telling you, 31 could potentially be any of them. All right? As long as you make an appropriate defense, you get full credit. Okay? So. Yeah. What did we drop? Hello? We drew neuromuscular junction and skeletal muscle contraction. So make sure you can tell me exactly what happens. Alright? So a signal comes down and it is released from a neuron. Okay? So acetylcholine is released, it binds. What happens inside the cell? Be able to do that. Okay. What other questions do you have? What else would you like?
What's up? Neuromuscular junction. What?
Yeah, neuromuscular junction and muscle contraction. I can go through it with like the last 7 minutes that we have if you would like.
Yeah.
Yeah, that's something you guys would like?
Yes, please.
Yeah, sure. Cool.
Take a video.
That's what I'm doing.
Taking a video?
Alright, so
Set up the
remember,
thing.
we get some kind of neuron that comes
Just hold
down,
it.
and it is going to interact with a muscle cell. Ooh, I'm going to do something here. So when it interacts with that muscle cell, it is going to cause a cascade of events inside the tissue itself. Okay? So these cascade of events are what we would refer to as a muscle contraction. Yeah, sure. All right. So I'm going to do this. Okay. What kind of signal is going to be sent here? Is that voluntary or involuntary?
Voluntary.
Okay, it's voluntary. And for the sake of time, I'm only going to draw this little section. All right, so it's voluntary. All right, so what neurotransmitter is going to be released from here first off? Acetylcholine. All right, so that's going to be good old ACH. Acetylcholine gets released out here because of what channels that open up in the cell membrane. Okay, so we get calcium channels that come in. That's going to bind with this, cause it to merge here, release acetylcholine. Acetylcholine is going to bind to what?
Acetylcholinesterase.
Family. Acetylcholine is going to bind to. Oof. It's going to bind to receptors, ligand-gated receptors. And those ligand-gated receptors are going to open up and allow what ion to come in?
Sodium.
Sodium. Okay, now remember, what is the general resting membrane potential for this?
Negative or 90.
Yeah, negative 90. Okay, so when it comes in, it peaks, does that number, goes all the way up to about plus 30 or so. Okay, so negative 90 resting membrane, what is going to be threshold potential? 55, negative 55 millivolts. Okay, so sodium comes in, causes this to get to about negative 55 millivolts. Okay, remember there are other sodium voltage gated channels all through here. They're also going to let in sodium. Okay, when it lets in the sodium, that's going to drive it to be close to plus 55, which will cause what kind of gated channels out here to open? Voltage, who said that? Dope, I'm gonna high five it later. So, right here, this is going to open at about our good old negative 55 millivolts. What's that going to let in? More sodium. And which is going to cause that positivity, or the fact that this is going all the way up to good old negative 55, all the way up to positive 30, and it's going to cause channels inside of, what's this big structure that should be here? The sarcoplasmic reticulum. Remember, we have that receptor here. What was that receptor called? That's a good old ryanodine receptor, right? And so, ryanodine receptor is going to change its shape in response to a voltage change, which means that we're going to go at negative 55. That's going to open a hole inside of this, which causes calcium to be released. Okay? Calcium is going to bop over here, and it will bind to this thing right here. What is this thing right here? The little stool structure. It's going to bind a troponin. When it binds a troponin, it's going to change shape, pick its leg up, which is going to move tropomyosin away from actin, which allows myosin and actin, or the thin and thick filaments, to bind to one another, making a cross bridge, which will then cause it to shorten. Once it shortens and that calcium breaks off, what happens? What happens when we hit plus 30 millivolts? So maybe we have like a little channel right here.
Potassium channels.
What happens at plus 30 millivolts? What channels open up to repolarize the cell?
Potassium.
Potassium, okay? So we get potassium channels that open up, K plus, at plus 30 millivolts. And at the same time, when that happens too, we're also going to open our, what's the other voltage gated channel in here? Somebody said it. Starts with the C and ends with alcium.
Calcium.
Calcium. So here at the plus 30 millivolts too, we're going to get calcium that's going to be pushed out as well. So at plus 30 millivolts, calcium gets pushed out too. That's going to drive the cell to become more negative. Okay? Calcium is also going to be reuptaken into the sarcoplasmic reticulum by various cotransporters. It might take a sodium ion, or it might take a hydrogen ion, and it will switch places with the calcium to put it back in the sarcoplasmic reticulum. Remember, the sarcoplasmic reticulum's concentration here, super high. Okay, so when I open that plug, lots rushes out very quickly. Very quickly. The signal gets sent, about 5 milliseconds. All of this occurs about 50 to 100 milliseconds.
What is the sarcoplasmic reticulum receptor right there?
Oh, this dude right here? What is this one called, guys, folks? Isn't that ryanodine? Ryanodine. It also is connected to a dihydropyridine receptor, by the way. But don't with that one. You're okay with that. Now, that's what happens. Ultimately, it repolarizes, depolarizes, etc. Now, fun fact. You guys ready for this one? These things are not just sitting in this one little place, are they? No, this is making up like 99% of this cell, okay? So I draw it very small here, but it's actually quite large. The full action of calcium is going to be, it's released from the sarcoplasmic reticulum, binds to troponin, unbinds, gets reuptaken, or pumped out, okay? There are these proteins that exist that link from here up into the cell membrane of this. So it goes all the way up to the sarcolemma, okay? And these are going to provide structure. They're structural proteins called dystrophin proteins. You guys ever heard of something called muscular dystrophy? Yeah? In folks with muscular dystrophy, these proteins cause the cell membranes to sag, which means that these don't contract as well. And folks with muscular dystrophy have a very hard time moving. And over time, they lose the ability to do so because these proteins break down. You can have a muscular dystrophy that is diagnosed when you're a kid. Those folks, unfortunately, don't last very long. Or you can have adult onset muscular dystrophy, which also results in this. One is because a folding of proteins is weird, and another one is because part of this just like isn't made. So, we're good. You guys should be perfect.